So hello everyone, in this video we are going to see what is race around condition in the JK flip-flop. Now if you remember, in the JK flip-flop there are total 4 NAND gates. From those 4 NAND gates, 2 NAND gates are 3 input, remaining 2 NAND gates are having 2 input. Now in this simulator, actually 3 input NAND gate is not available. But we can create 3 input NAND gate using one 2 input NAND gate and one 2 input AND gate. So let's take one 2 input NAND gate and let's drag and drop it to here, and let's take one AND gate. So let's select it and let's select and drag and drop it to here. So together it becomes 3 input NAND gate. We have to take one more 3 input NAND gate. So to create one more 3 input NAND gate, let's take one 2 input NAND gate and let's drag and drop it to here, and let's take one more 2 input AND gate. So let's select it and let's drag and drop it to here. Okay, let's put it here. Okay, now let's connect them. So this terminal goes to here and this terminal goes to here, and together it becomes 3 input NAND gate. Now let's take two more 2 input NAND gate. So let's drag and drop it to here, and we have to take one more 2 input NAND gate, and we will select this and we will put it here. Now let's find the LED. Now why we need the LED? We will use LED to check output. So we will drag and drop this LED to here, and if the LED is glowing, it means the output is 1 bit or it is high, and if the LED is not glowing, it means the output is 0 bit or low. We have to take two switches, and using this switch we can provide input to these gates. So we have to take one more switch and let's select it and let's put it just below the first one. Now after selecting the switches, we have to take one voltage source and one ground. In the digital electronics, when we need to provide 1 bit, we have to provide actually high voltage, and to provide the high voltage we have to use voltage source. And when we need to provide 0 bit, in that case we have to connect to the ground. So that's why we have taken one voltage source and one ground. We have to take one more voltage source and ground for the second switch. So let's take this voltage source and let's put it here, and let's take one more ground. So let's select and let's put this ground to here. Okay, now we know that because it is flip-flop we need clock, so that's why we have taken one clock, and to configure the clock properly we have to connect it to ground. Okay, fine. Now let's take one resistor to provide output to the another gate. Fine. Now we have to take one more ground for the LED. So let's select this and let's move this near to the LED. Okay, fine. Okay, fine. Now let's connect all the components together. So this connected to here, this connects to here, this terminal connects to here, and this to here. Now let's provide the feedback connections. Now we know that in the 3 input NAND gate, the one terminal is connected to clock input. So let's connect clock here. The another terminal to another terminal we have to connect the switches, because to that terminal we will provide some input, and the remaining terminal goes to feedback. So this to here and this to here. Fine. Now let's connect the one terminal of the switch to ground to provide 0 bit and another terminal of the switch to voltage source to provide 1 bit. Okay, fine. Now, in the digital circuit, each and every component should be working on same voltage level. So let's set this LED to 5 volt. So when 5 volt is given, the LED will glow, and when 0 volt is given, the LED will not glow. Let's set the clock to 5 volt too, and let's set this both voltage source. So let's set this to 5 volt. Okay, and let's set the other voltage source to 5 volt also. Okay, now let's name this terminal as J, this terminal as K, and the output as Qn. And let's play the simulation. Now we know that in the JK flip-flop, when J is 0 and K is 1, it means the output is low. So you can see that the LED is not glowing, it means the Qn is 0. In the JK flip-flop, when J is 0 and K is 0, we know that the output will not change. So you can see that J is 0 and K is also 0, so output is not changed. When J is 1 and K is 0, the output will be 1. So you can see that LED is glowing. Again, when J and K both are 0, the output will be unchanged. Now let's see the condition that we are interested to see. When both the terminals are 1, the output will continuously toggle, and this is known as race around condition. We can also see the waveform of the race around condition. So to see the simulation, let's select this terminal and let's play. So we know that when J is 1 and K is also 1, the output is in toggle mode. Okay, so waveform is continuously going high and low. When J is 0 and K is 1, the output will be 0. So LED is not glowing. When J is 1 and K is 0, the output will be high. And again, when J and K both are 1, the output will keep toggling. So this is race around condition.